This video will explain the scope of the quantifier operators. So, like negations, what will fall under the scope of the quantifier is the formula directly to the right of the quantifier. So, quantifiers are like negations in that they're unary operators. So, for a negation, what's under the scope of the negation is what's right next to it. So, if we have the formula not P, the P is under the scope of the negation. But if we had the formula not P and Q, well then only the not P is under the scope of the negation. Unless we put P and Q in parentheses. And then the negation, the whole formula P and Q falls under the scope of the negation. So, quantifiers are going to work in a similar way. So, for example, consider the formula for all x, px. Or the formula, there exists an x, parenthesis, px and qx. And finally, there exists an x, px and qx. So formula 3 has what are called free variables. Variables that are not within the scope of a quantifier. So for each of these, the scope of the quantifier in the first one is the formula px. So that's the whole formula that's there, and that's fine. It's all under the scope of the quantifier. And you don't need parentheses for that, because the quantifier applies to whatever is directly next to it on the right, so it's fine. Then the scope of the quantifier in the second formula is everything within the parentheses. So the parentheses binds that all together and makes it a chunk. And so then it means that what is directly next to the existential quantifier is that whole formula, px and qx. However, we don't have the parentheses, then the scope of the existential quantifier is just the formula px. And so then the formula qx is just kind of all by itself. It doesn't have a quantifier binding it. So that means that the x in the qx is free. And we don't like that. That's not a good thing. And it ends up making formula 3 a non-well-formed formula. So we can't have free variables in our final formulas.